Hello everyone. 1.4 is box plots. One advantage of a box plot is that it readily shows how the data is spread, or how spread out it is, etc. Box plots were invented in the 1970s. Who cares, right? Except that it was by a statistician named John Turkey, which is kind of funny because his last name was Turkey. All right, 5 key numbers are used to create a box plot. The minimum, which is least value. We typically just call that min. The first quartile, or lower quartile, which is the median of the lower half of the data. We call that Q1. Then we have the second quartile, which is the overall median. We call that Q2. We have the third quartile, or the upper quartile, which is the median of the upper half of the data. We call this Q3. And then we have the maximum, which is, of course, the highest value. Together, we'll call that the max. Together, the min, Q1, Q2, Q3, and max are called the 5-number summary. So if we look at the set of data, basically comparing here, your minimum shows up on the box plot on the far left. Then we have Q1, Q2, Q3, so the median's right there. And this is your max. The difference Q3 minus Q1 is called the interquartile range. Or IQR, because interquartile range is too long. The IQR is the length of an interval in which you will find the middle 50% of the data. It is the length of the rectangle in the box plot. So essentially how a box plot is arranged, you end up with, regardless of like how big each side is, 25% of the data is between the minimum and Q1, another 25% is between Q1 and Q2, another quarter is between Q2 and Q3, and the final quarter is between Q3 and the max. Okay, so we have an example. We have ages of the Best Actor Oscar winners from 97 to 2005, and we'll give the 5-number summary. Usually I start with the median. So I'll go to the middle. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. So we'll have 4 on each side. So our median, or Q2, will be 40. Then from there, you can find the median of either side. Q3 will fall between 46 and 47, so 46.5. That's Q3. And the median of the lower half will be between 36 and 37. That's Q1. And then our minimum is 29 and our max is 50. So for the 5-number summary, minimum is 29, Q1 is 36.5, Q2 is 40, Q3 is 46.5, and the max is 50. So sometimes people write the 5-number summary just in brackets here and go in order. So 29, 36.5, 40, 46.5, and 50. You're welcome to do it that way as well, as long as it's in the correct order. Now we'll draw a box plot. The key is scale. If you don't have a scale on the bottom of your box plot, the picture will not be accurate. So we know here we start at 29 and go to 46.5. So I'm going to maybe start at 25 and go up by 5. So 25, 30, 35, 40, 45, and 50. Make sure you always do this first, and then we can draw our box plot. So we start at our minimum, which was 29, so it's about there. I usually just make lines to begin with, and then our Q1 was 36.5, about there. Q2 is 40, Q3 is 46.5, the max is 50. So then the middle 3, we make a box, and then we connect the other 2. Okay? And again, the scale is important, because if you just draw a regular old box and put numbers, you won't be able to tell it. For example, Q3 minus Q2, that 25% of the data falls in a bigger range than this 25%, for example. Let's look at this graph of payrolls of Major League Baseball teams. It's a lot. So observations that are extreme, such as the $190 million payroll, are called outliers. A common method to identifying outliers is the 1.5 times IQR criterion. So any number larger than Q3 plus 1.5 times IQR, or smaller than Q1 minus 1.5 times IQR, is considered an outlier. And in a box and whisker plot, outliers are represented by values or points beyond the whiskers. So if we have the 5-number summary for that data, we're going to determine if there's any outliers. So if you picture a box plot, just a general one again, So Q1 is right here, and Q3 is right here. So when we're thinking of outliers, we're thinking they're to the left of Q1 or to the right of Q3, okay, a certain distance away. So the 1.5 times IQR method will take Q1, which in this case was 62, and we'll subtract 1.5 times the IQR. We need to know what the IQR is. It's Q3 minus Q1, not IQ3. I don't know what I'm doing now, just mixing stuff together. IQR, Q3 minus Q1, which is 100, minus 62, which is 38. So then back up here, we'll take Q1 minus, because we're going to the left of it, 1.5 times 38, which is, which should equal 5. And so again, this is the left of Q1. And then we'll go to the right of Q3, which was 100. So 100 plus 1.5 times 38, which is 157. And again, this is to the right of Q3. And so now the key is outliers are anything less than 5 or greater than 157, because less than is going that way, greater than is going that way. There's nothing less than 5, but there is one greater than 157, so our outlier is our 190 million. Okay? Take a minute, pause the video, do example 3 for me, try to match. Okay, welcome back. I'm assuming you paused it and came right back. So histogram A Since the data is clustered on the left, we'll go with box plot 2. Histogram B, since more of the data is on the right, we'll go with box plot 3. And this would be a tail skewed to the left for what it's worth. Histogram C is everything's kind of even. So we'll go with box plot 1.